So for this week's lab, we're doing the Aldol condensation, and the backbone of this mechanism is the enolate formation. So first, our alpha carbon on our carbonyl compound is highly reactive with our base. So our base is going to act as a nucleophile, stealing this hydrogen and pushing these electrons in on the alpha carbon, thus forming the carbanion. So for the carbanion, this one in particular has a partially positive carbon, which is going to allow these electrons to push in, pushing this bond onto the oxygen. This adds on a lone pair and a negative charge. And since these electrons moved from the third carbon to the second carbon, this forms a double bond right here. Out of these two resonance structures, this one is more stable because oxygen prefers the negative charge. And since this is more stable, we will be carrying out the rest of our reaction with this resonance structure, as it's more reactive. In step 2, the third carbon on the carbanion acts as a nucleophile, attacking this partially positive carbon on the aldehyde or ketone, thus pushing this pi bond up on the oxygen, creating a new CC bond, as shown in purple. So this black part comes from our carbanion. The purple part is our bond we just formed, and this blue part is any 1 mole of aldehyde or ketone, thus creating a negative charge on this oxygen. So one of the lone pairs from our oxygen is going to attack this hydrogen, breaking this bond and forcing it in on our oxygen, thus forming our aldol product. Step 3 is dehydration. So we have this OH floating around in solution. It's going to attack one of the alpha hydrogens, forcing this bond onto this carbon-carbon bond. And since this creates too many bonds onto this carbon, the OH will go ahead and leave, forming a double bond from your alpha carbon to your beta carbon, which is known as an alpha-beta unsaturated carbonyl compound.
So for today's experiment, we're going to be doing a mixed aldol condensation. We're going to have 2 moles of benzaldehyde reacting with 1 mole of acetone. And since there are 2 available sets of alpha hydrogens, this can react twice to form dibenzyl acetone. This cannot act as the nucleophile because there are no alpha hydrogens available on the molecule. So in the first step for this reaction, we have to form an enolate anion. So OH will attack the alpha hydrogen on acetone, and so these lone pairs will collapse onto the alpha carbon, creating this carbanion. In this step, the lone pairs on the carbanion will attack the carbonyl carbon, which is partially positive. So then these electrons on the pi bond will move up onto the oxygen. And by the way, this is the first mole of benzaldehyde we're using. So skipping a few steps ahead, we've already formed the aldol, so then we're going to dehydrate it, and then we get this product. Okay, and as you can see here, there's still going to be alpha hydrogens on here. So going back down to here, here's the alpha hydrogen we're going to attack. We're going to form another enolate anion. The OH will go to here. These lone pairs will come down onto the alpha carbon. So once we have formed the second carbanion, the lone pairs will attack the carbonyl compound of the second mole of benzaldehyde. And so these electrons will go up, and then skipping a few steps ahead, we've already made the aldol product, and then we add OH, and once they're dehydrated, we form dibenzyl acetone.
A possible side reaction is a Cannizzaro reaction. This can form whenever the OH attacks the benzaldehyde instead of the enolate formed from acetone.
Okay. Thank you guys for watching.